Alright guys, welcome to this page of the notes. What we've got here is another word problem where you will need to set up a system of equations and then solve that system of equations. This one actually is a favorite of mine. I love this word problem, and not just because it's about amusement parks, because there's a lot of neat little tricks in this one that you got to kind of watch out for. Really a lot of fun. So here we go. Nick. Nick goes to an amusement park. He rides roller coasters, bumper cars, and water slides. And I give you a little bit of information, but before we do that, let's go ahead and assign variables. This hopefully will make sense to you. Roller coasters, let's go ahead and call those R. Bumper cars, let's go ahead and call those B. And water slides, yep, you guessed it, let's call those W. Makes sense to me. Now, here's what happened. The wait time for the roller coasters was an hour. The wait time for the bumper cars was 20 minutes, and the wait time for the water slides was 15 minutes. Nick rode a total of 10 rides. Hey, go ahead and highlight it since I already told you. It was a total. You know you're looking for totals. Might as well highlight it while you're here. Rode a total of 10 rides during his visit. The number of times Nick rode a roller coaster was the sum of the times he rode the other two types of rides. If Nick waited in line a total, there it is, a total of 6 hours and 20 minutes, how many of each ride did Nick go on? So how many roller coasters did he ride? How many water slides did he ride? And how many times did he ride the bumper cars? Here we go. Since I've got my totals, let's write those equations. He rode a total of 10 rides. I don't want yellow, give me black. There it is, 10 rides. Now, those rides, well, what did he go on? Well, he went on roller coasters, bumper cars, and water slides. So if you add up the number of times he rode each of those, you would get the total of 10. So 10 is equal to the number of roller coasters, plus the number of bumper cars, plus the number of water slides. Right? That's how he rode a total of 10 rides. The next total is 6 hours and 20 minutes. That's how much time Nick spent standing in line waiting to go on these rides. And here's where this problem gets interesting. My units don't match. Yeah. Nick waited an hour for a roller coaster, 20 minutes for bumper cars, 15 minutes for a water slide, 6 hours and 20 minutes. Please notice that I'm using both units of hours and minutes. That is not okay. You need to pick a set of units when solving this problem and stick with it. Now you've got an option. You can either convert everything to hours or convert everything to minutes. And I think that the minutes is actually probably going to be the easier way to go. So here we go. A total of 6 hours and 20 minutes. If you got a calculator with you, of course there are 60 minutes in an hour. So 60 times 6 gets you 360. So this is 360 minutes. But he didn't just wait 6 hours, he also waited an additional 20 minutes. So 360 minutes plus that additional 20, 380 minutes. Total amount of time that Nick spent waiting in line. Now, where does that time come from? Well, 60 minutes of it comes from the roller coasters. Okay. 20 minutes of it comes from the bumper cars, and 15 minutes comes from those water slides. Got a problem. I got two equations because I only had two totals, 10 rides and a total wait time. But I've got three unknowns, and I can't solve three unknowns with two equations. It doesn't work that way. If I have three unknowns, I must have three equations. So what am I supposed to do? Well, I must have missed something. So let's go back to the problem. And there it is, right there. The number of times Nick rode the roller coasters was the sum of the times he rode the other two types of rides. Actually, let me put it in blue so it doesn't mix up with the rest of my stuff. There we go. Yeah, this is going to help me write my third equation. Here's what it says. If you add together the number of times he rode the bumper cars and the water slides, add those together, it's equal to the number of times he rolled the roller coaster. That's easy. R is equal to bumper cars plus water slides. But I don't really like that, right? Because I need a number over here, right? 10, 380, R. Let's move the R to the other side. And so here's a better equation. 0 is equal to minus R plus B plus W. Much nicer. There's equation 1. There's equation 2. There's equation number 3. We're all set. Let's see how this goes. Ooh, I like it. Look at this. I have a positive R. I have a negative R. If I add those equations together, the R's will drop out. That looks like it's going to be the way to go. So let's do it. We're going to add and 1 and 3. 10 equals R plus B plus W. I will have 0 equals minus R plus B plus W. Add them up. R's drop out. And we wind up with 10 is equal to 2B plus 2W. I got myself a new equation. So we number it. Beautiful. I love it. All right, here we go. Now what I need to do is figure out another way. Since I eliminated R in this one, I got to eliminate R again. All right, let's see what happens here. I like equation number 3. I think I'm going to stick with it because it's negative. But since I already added number 3 to number 1, my only other option now is to add 2 and 3. And since equation number 2 has a 60R, if I multiply this equation by 60, those R's should drop out. So let's do that. So if I take 380 is equal to 60R plus 20B plus 15W, I multiply everybody here by 60. That's going to give me 0 is equal to a negative 60R. Perfect. That's what I want. That'll go away. Plus 60B plus 60W. Add them up. Those guys drop out. Let's see. 60 and 20 is going to be 80B. And 15 and 60 should be 75W. All right, awesome. Well, here we go. I just got a new equation. Make sure that you number it. And here's what we've got. I've got this equation, which has a B and a W. I have this equation, which has a B and a W. I need to either get rid of the B's or get rid of the W's. Which one's going to be easier? Well, neither of them have opposite signs, so that doesn't help any. Neither of them have the same coefficients. Great, so we go LCM. Well, the least common multiple of 2 and 80 is actually 80. 80 is a multiple of 2. 2 and 75, yeah, that's going to be something big. So we're going to go ahead and get rid of the B's. That's going to be the smallest LCM. So here we go. Let's add 4 and 5. And in order to get rid of the B's, I'm going to multiply this one by a negative 40. All right, so I'm going to add 10. Okay, let's go ahead and rewrite those equations now that I'm doing this multiplication. Negative 40 times 10 should be a minus 400. Oh, I'm going to wind up with negative numbers. Bummer. That's all right. I guess it happens. That gives me my negative 80b. Awesome. Oh, wow, look at that. And the negative 80w. Sweet. Okay. 380 is 80b. Yep, those will drop out. 75w. All right, I'm going to wind up with negative numbers. I guess I probably should have been a little smarter, although there may not have been any way to avoid it. I'm sure there was a way, but I just didn't do it. Anyway, b's drop out. It's too late now to go back. And I wind up with, how about a minus 20 is equal to a negative 5w, which means w is equal to a positive 4. So here's what I know. He rode the water slides 4 times. 4 times he rode a water slide. Great. Let's keep going. I need to figure out now how many times he rode a bumper car and how many times he rode a roller coaster. Well, you've got your pick. You can either put W in here or put W in here. I know which one I'm picking. Those numbers are way easier. Erase that so it's not in my way. And here we go. I got 10 is equal to 2b plus 2w, but I know that w is equal to 4. 2b plus 2 times 4, which means I have 10. Minus 8 is equal to 2b, which means 2 is equal to 2b, which means b is equal to 1. So he only rode the bumper cars one time. One time. I guess bumper cars aren't his favorite. That's all right. That's okay. Now I need to figure out how many times he rode the roller coaster. Well, actually, this is where this equation comes in handy. If I add the bumper cars plus the water slides, I know how many times he rolled the roller coaster. So that is definitely the way to go. Here we go. R is equal. There we go. R is equal to bumper cars plus water slides, which means R is equal to 1 plus 4, which means, look at that. That's not a bad day. 5 roller coasters in one day. That's a lot of time upside down. Anyway, here we go. You have got your answer. The question was, how many of each type of ride did Nick go on? He went on water slides 4 times. He went on the bumper cars once, and he rode 5 roller coasters. All in all, a pretty good day. Guys, thanks for joining me for this set of videos. Hopefully now you feel comfortable solving systems of equations with 3 variables, which means you have 3 equations. Thanks for joining me. I'll see you next time.